Hi guys. I know you guys are working away on some of your homework, so I thought I'd take advantage of this time, put up a video and take up some of these, save us some time in class. Let's look at the first one. I'm going to start off by trying property number 7. Property number 7 is simply plug it in and see what happens. So I'm going to get pi, cos pi squared. Cos of pi, let's see if I can remember. Pi by 2. Pi, so cos starts here, goes here, so it's going to be -1. So it's going to be pi -1 squared. It's going to equal pi. Now I simply could have put in cos of 180 and got the same answer, but I don't have a calculator. I'm not sure where it went. I'm not impressed, but my calculator's gone missing. All right, number 2. And this one is limit as x approaches pi by 4. I'm going to try property 7 again, see what happens. I'm going to get tan of 3, 4 over 3, over top of 4, pi by 4. I said 4 over 3 and wrote pi over 4. Don't worry about it. It's late. Let's see. This is going to give me tan of, that's 135 degrees, I think, over top of pi. 135 degrees is over here. And again, I'm doing this because I don't have a calculator. So this is 135. So this is 45. So the related acute angle is 45. So it's going to be 1 root 2. So it's going to be 1 over 1, which is 1. But I'm in quadrant 2, which only sign is positive. So the tan will be negative. So it's going to be -1 over pi. And again, if you use your calculator, it'll be a heck of a lot easier. Let's look at the next two. The limit as sine, so if I allow property 7 to happen, it'll be sine of 0 over 0, which is indeterminate, so I need to do some work. There's a theorem that I can use here, but I'm happy to think about it, and that would be, what I would really like to do is to get a 4x on the bottom. So if I multiply top and bottom by 4, I'm going to be left with, this 4 is going to come straight out, I don't need it. So 4 limit x approaches 0 of sine 4x over 4x. Now as x approaches 0, so does 4x approach 0. And again, there's a theorem for this, but I'm not much of a memory guy. I see the pattern here. All of these are the same. So the limit as 4x approaches 0 of sine 4x over 4x is 1. So the answer is going to be 4 times 1, which is 4. Here's the next one. I've got 3x and 5x. I think what I'll try to do here is divide top and bottom by x. So it'll be sine 3x over x and sine 5x over x. Notice that that can be changed into the limit as x approaches 0 of sine 3x over x over top of the limit. Can't see? I better come out a bit. Maybe I'm focused in too high. Limit as x approaches 0 of sine 5x over x. Same as what I was doing over here. The only difference is I think I'll apply the theorem this time. So this one's going to be 3 and that one's going to be 5. Let's look at the next two. So tan of 0 is 0. 3 times 0 is 0, so that's indeterminate, so I have to do some work. So I don't know any theorems with tan, so I'm going to change it to sine x over cos x. And that's all going to be multiplied by 1 over 3x. What I'm thinking about here is getting a sine x over 3x, or a sine x over x anyway. So I'm thinking of breaking this up into sine x over x times 1 over 3 cos x. Taking a look at those limits separately as x approaches 0. This is going to go to 1. As x approaches 0, cos x is going to 1 as well. So what we're going to have is 1 times 1 over 3 times 1, which is 1/3. Looking at this one, I've got cos squared x, that's a bad thing. I see I've got x squared on the bottom, so I'm thinking of sine squared x over 2x squared, because I know that sine squared x plus cos squared x equals 1. So therefore 1 minus cos squared x equals sine squared x. So now I can break this up. I got enough to go around. So the limit of sine x will be 1, the limit of sine x will be 1, the limit of this is going to be 1/2. So if you wanted to, you could write it out. I'm not seeing much point in it. So 1, 1, that's a constant. Answer's 1/2. Okay, next two. I think I'll divide top and bottom by 1 again to get that sine x over x that I like so much. So it's going to be sine x over x all over top of x over x plus sine x over x. Notice that that also could have been written like this. It's just more convenient in this form. So it's going to be the limit as x approaches 0 of sine x over x over top of the limit as x approaches 0 of 1 plus sine x over x. Looking at this, you can tell that that's going to go to 1, that's going to go to 1, that's going to be 1, so it's going to be 1 over 1 plus 1, it's going to be 1 over 2. Taking a look at number 8. I could make this 1 minus cos squared, and then it could be 1, I could do difference of squares and 1 plus, and that might be interesting. The other thing I can do is I can multiply by the conjugate. I'm going to try something. If it doesn't work, I'm going to do something else. I'm going to make this 1 minus cos squared x, cos x over 1 minus cos x. This one is a difference of squares. Limit, x approaches 0, 1 minus cos x, 1 plus cos x, over top of 1 minus cos x. Now, I have the limit as x approaches 0 of 1 plus cos x. As x approaches 0, cos x will approach 1. This one will approach 1, so I'm going to get an answer of 2. That's not the only way to do that, but it's kind of neat. There's other ways. You could also try multiplying by the conjugate, 1 plus cos x over top of 1 plus cos x, and work on that. Let's see what's here. Number 9. Double angle formula here. That might be interesting. I don't think so, though. I think I can take care of that. I think we can look after this. Let's see. Sine x and a cos x. What if we do this? Limit as x approaches 0, 2 sine x over x cos x minus limit x approaches 0, sine 2x over x cos x. I like it, because what I'm going to do is I'm going to change it to the limit as x approaches 0, sine x over x times 2 over cos x, subtract limit as x approaches 0 of sine 2x over x times 1 over cos x. Separate those two limits. So it's going to be the limit sine x over x and multiplied by the limit as x approaches 0 of 2 over cos x minus the limit as x approaches 0 sine 2x over x times the limit as x approaches 0, 1 over cos x. Let's see what we have. That goes to 1. X approaching 0, cos x approaches 1. X approaches 0. This is using the theorem. I would multiply top and bottom by 2. That would give me a 2x here. The top 2 would come out, so this is going to go to 2. That's going to go to 1, so I'm going to end up with 1 times 2 over 1, subtract 2 times 1 over 1, which is going to be 0. That was a neat question. I like that one. Okay, let's see where I am now. Number 10. Number 10, I think I'll do this. Limit as x approaches 0 of sine 2x over top of x, 2x plus 1. That's kind of cool. That's going to leave me with the limit as x approaches 0 of sine 2x over x times the limit as x approaches 0 of 1 over 2x plus 1. This, the 2 and the 2, so I'd multiply by 2 over 2. It would give me a 2 here. The top 2 would come out using that theorem. So that's going to be 2. X approaches 0. This is going to be 1. That's going to equal 2. Let's make sure that 9 and 10 were what I was supposed to. Yes, they were. I got what I needed. And the last one, dun dun dun. Limit as x approaches 0 of 1 minus cos 2x over x squared. Thinking about this. Double angle formula is pretty straightforward. I could use a double angle formula here, which would be limit x approaches 0 of 1 minus, so it's going to be cos x minus sine x sine x, because remember that cos of 2x is simply cos x plus x. So that'll be over top of x squared. So then take the negative in, it's going to be the limit as x approaches 0 of 1 plus sine squared x minus cos squared x over top of x squared. Well, I can do this. It can be the limit of x approaching 0. Maybe I'll rearrange it. 1 minus cos squared x plus sine squared x over x squared. This we know equals sine squared x plus sine squared x. That we know is going to equal 2 sine squared x over x squared, which will be the limit as x approaches 0 of 2 sine x over x times sine x over x. Limit of 2 is just going to be 2. That'll go to 1. That'll go to 1. Answer should be 2. Let's check. And it is. And there's another way to do this question. Remind me tomorrow, and I'll see if I remember it. Okay, guys, there you go. That's your homework done.